We started section 7.3, repeating decimals last time, and I believe we left off with me making some of you very, very uncomfortable about the fact that 0.9 repeating was equal to the number 1. Does that sound right? Very uncomfortable. So we're going to pick back up right after that with finding a decimal, therefore, between the number 0.9 repeating and 1.1. So if you recognize quickly enough on this one, whether you like it or not, that 0.9 repeating is the number 1, and this is the number 1.1. Can you give me a decimal between those two numbers? What is it? What would be a number between them? 1.02 would be an acceptable answer. Anybody else have another option? There's infinitely many options. So somebody give me another option. 1.05, that would be halfway, wouldn't it? What else did you have, Kayla? 1.01, yeah. So we have lots and lots of choices that are going to be between those. And I'd like to take a look at what happens with you. Oh, wait, on part B, we already answered that since I just kept talking. 1.05. I'd like to show you how you would find if it weren't. I mean, this is the number 1, right? How do you find the number halfway in between if you aren't quite sure what to do, or if it is a repeating decimal and you're not sure that you really want to change it back to a fraction to work with it? So what you can do is you can actually take whatever decimal you're given, and I'll use this one since I have it, and write out many digits of it. Okay, so I'll go with 6 for now. Something like that should be sufficient. And to find the midpoint, the halfway point between two values, it's just an average. You add them together and you divide by 2. So grab your calculator, if you will, and add my 6 nines, right, 0.69s, to the 1.1 and divide by 2. And somebody tell me what you have, and we'll talk about how we interpret it to actually make sense, because we really didn't use the 0.9 repeating, right? We just put a several nines there. So what does your calculator give you as the answer? Like with all of its decimals. What do you have, Julie?
1.04.
Does it have several nines like this?
4 nines.
4 nines. And then a 5. Does it look like that?
4 nines and then a 5.
That way? Lovely. Okay. So this is clearly not exactly 1.05. So why did it do that? Why did it give me 1.049995? 99995. Why didn't it give me 1.05? We put in something close to 0.9 repeating. That's exactly right. So what's happening is that your calculator is interpreting as best it can based on the fact that you rounded when you put the digits in. And this should actually be 1.05 if we had written in all the nines as if that were an actual thing we were able to do. Okay? So you can, it's not tricking the calculator, but you can actually use the calculator to your advantage on a problem like that by simply using the repeating decimal enough times to give yourself a sense of what's really happening in the problem to find the halfway point. Does that make sense? Okay, you've got an example. I think it's in the group work where you're going to do a problem like this. All right, example 7. Some addition problems are easier to compute with fractions, and some are easier to compute with decimals. For example, 1/7 plus 5/7 is easier to compute than the repeating decimal 142857 plus the repeating decimal 714285. Right? I don't want to add those repeating decimals together. That looks terrible. But 1/7 plus 5/7 is very quickly 6/7 in my world. And then another example, 0.4 plus 0.25 is easier to compute than 2/5 plus 1/4. So in that case, the decimal is easier to compute than the fraction. It says describe situations in which you think it would be easier to work with fractions than decimals, and vice versa. So we're just going to make a list of a few items of times when it's easier to use fractions, what problems work easily with fractions, and times when it's easier to use decimals. So we're going to say it in a positive sense as I want to do it when it's this way. I don't want to say it in a negative sense as I don't want to do it when it's like that, okay? We just need to decide. So when is it nice to use fractions? Can you give me an example or a description of when fractions are easy to add? Same denominator, you betcha. Okay, let's pause on that then. How about decimals? When do you like to add decimals? Anytime? I don't think that's true, Alicia. You don't want to add these decimals together, right? Okay, when they're terminating, right? Terminating decimals are super friendly. All right, terminating, and the ones we're working with means non-repeating, right? It's just a positive way of saying it instead of a negative way of saying it, right? Terminating. And if you think about if I asked you to say it in a negative sense, when are fractions not so nice? They're not so nice when they don't have common denominators. And I'd like to kind of throw in the same denominator or easy to find. I'll just write CD for common denominator. There are some denominators that are common, they aren't common, but they're easy to find, right? Like if I had the fractions of 1/4 and 1/2, those are not hard to find a common denominator. But if I have 1/35 and 1/62, none of us wants to do that, right? They're harder to find. Decimals are nice when they're terminating. They also tend to be nice when they're not very long, right? The longer the decimal expansion, the messier it kind of works with, right? So I'm going to say fewer places or fewer place values. That's another time when it's nicer to when it's nice to use decimals is when there's not very many place values present. Because honestly, even without the repeating, the ones that I circled would not be super fun to add together. They're 6 digits long, even without the repeating bar, right? It's not super nice to add together. All right, any questions on those? All right, we'll stop with long enough for you to do the group work on this today so that this assignment will be due on Wednesday when you come back.